So for the first piecewise function, f of x, when x is less than or equal to 0, we have the parabola y equals x plus 2 quantity squared. Now, this parabola has a vertex at negative 2, 0. And when x is less than or equal to 0, if you just replace x with 0, you get 0 plus 2 squared. 2 squared is 4. So we know the vertex of the parabola is, like I said, right there at negative 2, 0. And the parabola without a domain restriction over here would continue to go up this way past the y-axis. But again, when x is equal to 0, the endpoint of this piece has the ordered pair 0, 4. And it's just the quadratic function, vertex at negative 2, 0. And then we have f of x is defined to be the linear function 3 minus x on the interval from 0 to 3. So 3 minus x, if you think about 3 minus x as 3 minus x is the same as negative x plus 3. So if you put it in slope-intercept form, then you can see that the slope is negative 1 with a y-intercept of 3. And 1, 2, 3. But so x is not allowed to be equal to 0 for this piece because it was already equal to 0 for the first piece. So if we have a closed circle there, we have to have an open circle here. And so this function would have a y-intercept of 0, 3, and again a slope of negative 1. So down 1 and over 1, down 1 and over 1. We can keep going down 1 and over 1 until we get to x equals 3. And when I just put in the endpoint, plug in x equals 3, 3 minus 3 is 0, but there has to be an open circle there because of that. X has to be less than 3, so it can't be equal to 3. Then you just connect those two endpoints with a straight line segment. And then finally, x is equal to 0 when x is greater than or equal to 3. So actually, if you were to replace x with 3, then you'd get 0. So we can fill in that open circle with a closed circle, and then the rest of the graph is just the rest of the graph of f of x is the horizontal line that on the interval from 3 to infinity. So that's the graph of that piecewise function, f of x. And let's cruise on down here and find in these problems down here below the graphs where we're trying to figure out the value of f at a certain number, a certain input. So if the input is 2, for problem number 1 here, f of 2, we don't even have to look at the graph. We can just replace x in the second piece with 2, because since 2 is less than or is in between 0 and 3, we would replace this x with 2, and we'd get 3 minus 2, which is 1. So 1 is the value of f of 2. So 1 is the value of f of 2. F of 0. Now f of 0 is just 0 because, f of 0 is 4, and because if x is less than or equal to 0, you replace x with 0 in the first piece. So 0 plus 2 squared. 0 plus 2 squared is 2 squared, or 4. One thing I didn't point out with with this problem here, I didn't point out that when x is equal to 2 and y is equal to 1, we have the ordered pair 2, 1, and we can always double check to see if we did that right by seeing if the point 2, 1 is actually on the graph of f, and it certainly is. Same with when x is equal to 0 and y is equal to 4. That yields the ordered pair 0, 4, and sure enough, 0, 4 is on the graph of f of x. And then problem number 7, f of 1000. Well, clearly 1000 being the x is greater than or equal to 3. And so when the inputs are greater than or equal to 3, the outputs are always just 0. All right, so that takes care of the f of x piecewise function.